Good morning, and I hope you did well on your quiz. Now we're going to learn about some trig functions of any angle, 9.3. And we're going to start off by looking at the sine, cosine, and tangent of these angles in the figures. Now, just let me point out that all of these circles have radius 1. So on all of them, this length is 1, this length is 1. So we could construct a right triangle on here, and by these coordinates we can see that if this is a length of 1, then these sides, both of them in this case, are going to be have a length of root 2 over 2. Now you remember from the other day that when we have negative 1 over root 2, that's the same thing as negative root 2 over 2. And likewise, this one would be positive root 2 over 2. That thing about rationalizing the denominator. But that's going to happen when we have a hypotenuse of 1, then we're going to have, and both of our angles obviously are 45, because this is an isosceles right triangle, and that's going to have leg lengths of root 2 over 2. Now this one here shows that that point, there's not really a triangle there, but we have a point at 0, negative 1, and so what and this angle, it goes like this to there. So that's either 270 or 3 pi over 2 as we know it. All right, so what are the sine, cosine, and tangent of each of these? And over here in your margin, it shows that you can find the sine by taking the y-coordinate of the point over the radius. Now, in this situation, we have, as I said, in all of these, we have radius 1. So sine is y over r, cosine is x over r, and your cofunctions have r on top, but once again, r in all of these circles is 1. So it makes it easy. So I'm going to list in order sine, cosine, tangent as we go across. So the sine is the y value, and again it's over 1, so it's just going to be root 3 over 2. The cosine is going to be negative 1/2, okay? And it's negative because we're in quadrant 2, and that's the cosine would be negative in quadrant 2. Then the tangent is the y-coordinate over the x, and I'm just going to write up here how this happens because I have room up here. So root of 3 over 2 is the y-coordinate there. The x-coordinate is negative 1/2. Now what's going to happen if we divide that complex fraction is that we're going to end up with root 3 over 2 times, because of inverting the divisor, negative 2 over 1. So these 2's are going to cross out. It's still going to be negative, and this tangent is going to be negative root 3. Now, on the next one, by putting this ordered pair here, I've already told you that the sine is the y value there, root 2 over 2. The cosine is negative root 2 over 2. And if you put y over x in this case, it's numbers divided by themselves are just 1, although this was a negative root 2 over 2 divided by a positive root 2 over 2, so we end up with negative 1 for the tangent. On the third circle here, this third angle, as we talked about earlier, it's 270 or 3 pi over 2, either one. But the x-coordinate is 0, the y-coordinate is -1, so the sine is -1, the cosine is 0, and the tangent in this case, because we would have y over x, that's -1 over 0, which is, I'm going to say undefined. I'm going to just write that symbol to show that it's undefined. You can't divide by 0, so that's undefined. So let me just make a note up here that I'm showing the sine, cosine, and tangent in that order in each case for each circle. All right, on this one down here, we have the sine is -√3 over 2. The cosine is +1/2. And that's for this angle going this way. And the tangent is going to be, again, -√3 for the same reason as we had before, because we're going to put this, it's going to be that same thing I did up here. And it's going to be, although the negative came from the √3 over 2 this time rather than from the 1/2. We've got another angle halfway in between, so this is going like this, but the sine is negative this time, -√2 over 2. The cosine is +√2 over 2, and the tangent this time, again, is -1 because we had negative over positive. Over here on this circle with an angle of either 180 or pi, the sine is 0, the cosine is -1, and this time we can actually do y divided by x. 0 divided by -1 is 0, so the tangent on that one is 0. Sorry you couldn't see that. Like that. Okay, now down to this first example, and what these definitions in the margin allow us to do is to set up a triangle in any place, for any angle, and find the 6 trig functions. So in this case, the graphic here shows a little bit of what's going on. We have -4 is the x-coordinate, so you're 4 to the left of the origin at this point, and your y-coordinate is 3, so you're 3 above the origin at this point. So this is really, this is a length of 4, and this is a length of 3, and if we look at this, that would be a length of 5 there, because that's a 3, 4, 5 right triangle. Agreed? 3 squared plus 4 squared equals 5 squared. That was the basic, most classic Pythagorean triple we talked about the other day. So the sine of this angle theta is going to be 3 y over r, so that's 3/5. Cosine is going to be x over r, and that's the -1. Cosine is going to be negative in quadrant 2, so -4/5. Tangent is y over x again, so that's -3/4. Okay, so that's y over x. Now for the cosecant, remember that's just the reciprocal of sine, so all we have to do is flip this upside down. So that's 5/3. And the cosine, we're going to flip, or I'm sorry, the secant is the reciprocal of the cosine. The secant is the reciprocal of the cosine, and that will be 5 over negative 4. And you can put that on a fraction. You can put the negative on the top, on the bottom, or in the front, but it is a negative fraction. And the cotangent is going to be the reciprocal of tangent, so that's going to be negative 4/3. All right, time to turn the page. I'm going to draw another triangle similar to the one that was on the prior page to show what's going on. Well, we have, and my triangle might not always be to scale, but this is approximately where the point 5, negative 12 would be. Okay, and for that, we can make a triangle like this, where this should be a length of 5 because we're 5 to the right of the origin, and we're 12 down from the origin. And by Pythagorean theorem, 5 squared plus 12 squared equals 13 squared. So that's going to be 13 for the hypotenuse. Okay, I said that we would need to know the Pythagorean theorem really well and be able to easily find the third length of a right triangle. All right, so using that definition of y over r for the sine, it's going to be negative 12 over 13. For the cosine, that would be x over r, so that's going to be 5 over 13. The tangent is going to be, we can look at it either as opposite over adjacent or y over x, and this would be negative 12 over 5. Okay, then the reciprocal functions, cosecant of theta, just flip this upside down. Once we know that, it's easy, 13 over, negative 13 over 12. Secant of theta, the reciprocal of the cosine, 13 over 5. And the cotangent, reciprocal of the tangent, negative 5 over 12. All right, so we're going to pause there and start section 2.